Okay, welcome back everyone. I'm going to go through a very quick little video on the family of equations dealing with polynomial functions specifically, just to clear up sort of what we mean when we say families. Again, sort of in the advanced functions course, we don't worry about maximums and minimums. So what that means is if you draw a graph that kind of looks like this, and somebody else draws a graph that looks like this, oops, essentially that's the same graph, other than the fact that we maybe didn't have the same contact point here. So what that means is when I'm drawing one of these graphs, whether the question says sketch the graph of a cubic function with zeros there, draw an example of a cubic function from the family with zeros there, it's essentially asking me the same thing, which is put down the information that you should know given this, given what's written, and then do the best you can. So if I'm looking at this, I have zeros at -3 right here, -1 right here, and 1, 2, 3, 4, and 5. Okay. Now basically there's no indication here as to whether my graph is going to go up or go down, so that means I should at this point have the option. I can sort of think of this as my equation, one possibility, kind of answer one of the later questions right now anyways. Another possibility would be that I'm thinking of it as something like this. You know, again, all I know are the zeros themselves. And out of room, can't quite get that in there. And another possibility is actually something, I can think of it in terms of something like this. Now normally I would probably suggest that the graph is either opening up or has a negative first coefficient or a positive first coefficient, or depending on what type of graph it is. But if it doesn't state, then really all you have to do is show that you understand the content. So right here, I've got, I'll do a red one here first. Again, I don't know what this does. I don't know how far it's causing my graph to go up and down for maximum minimums. What I do know is that those blue spots that I made initially will be zeros of my function. So if I'm thinking of it in terms of this graph right here, I want to recognize what happens on the endpoints. And if I'm looking at 1, 2, 3 x values, so if I deal with a x being some sort of negative value approaching negative infinity, then my y value will also approach negative infinity. So out here somewhere, my graph is going to head down unto forever. On the other side, x approaches positive infinity, y approaches positive infinity. Probably don't even need to know that because I know that I've got 3 zeros. I know that I have a cubic function, but no, it's fine that I did that, which means that from this point forward, my graph is heading off into infinity. I should be a little bit more careful with that. It's not a straight line. It's just kind of heading off this way. And then what happens in between is something like this. Very poorly drawn, obviously. But if I just sort of thought about the first part and then continued on with the second part, I would end up with something more or less that looks like that. So continue on out of here and just on to infinity. If I did want to think of it in terms of this green equation, the only difference, of course, is that because of the negative value out front for that coefficient, my x value will be approaching, as x approaches negative infinity, my y value will actually approach positive infinity. And as x approaches positive infinity, my y value will approach negative infinity, which means, again, sort of with the green, it's going to kind of head down out this way somewhere. Heading out this way, it's going to head out this way somewhere. And then whatever I do from there, I've come up this way. And something along those lines is a fine example of what I know for this family of equations. Okay, so if I don't know more detail, I can't really say, did the graph go to this point? Did the graph go to a much more extreme point? Something like this. But it's the best I can do. Make sure I hit those zeros, make sure I know if I'm going up towards positive infinity or down towards negative infinity in all cases, and then know that I have to hit those zeros and understand what's going to happen at the zeros themselves. Okay. If I change the question up a little bit, I wonder if I can clone this page. And if the question instead said, make it a quartic function, so I'll sort of get rid of most of this. Just decided to do this at the last minute, sorry. And it gave me that, in fact, I had a double -1. Again, either wording here is fine. What I know then is I have zeros at the same spots. I'll give myself a bit more room this time. 1, 2, -3, -1, 1, 2, 3, 4, 5, which means that my equation looks something like this. And from the notes, if we paid attention, we recognize that this tells me that at that point, I'm going to have kind of a mini parabola. So I'm either going to have something like this, or I'm going to have something like this at x equals -1. So as far as that goes, the rest of the question, handle it the same way. I need to know my end point, what's going to happen. As x approaches positive infinity, what is y going to do? As x approaches negative infinity, what is y going to do? In this case, I have 1, 2, 3, 4 x values. So you put in a large positive number, multiply by itself 4 times, we get positive infinity. Put in a large negative number, we will once again get positive. So basically, I know that my ends are going to head off something like this. At -3, I'm continuing on through. And then at -1, I get my little mini parabola. And then at -5, I'm coming back up through. So essentially, that's what my graph looks like. If I had chosen to do an opposite, sort of think of it as a negative value out front and the rest of it, get just the opposite idea. I still have, I'm going to have some sort of a cup or parabola there. I would have a negative value coming up to this point, and then it would continue on and go down to the negatives this way. Okay. So again, basically that's if it's quartic, only because I need to have that fourth exponent in, and so where the double exponent is at -x plus 1 being squared, I get kind of that parabola instead of actually having to go through the line. So give an example of an equation that fits the family from example 1. I did that several times. Any of these, sorry, on this first page, any of these are examples that fit given the information. What's the general equation of that family? Well, if we sort of look back on the first example, what we see is that The bracketed expressions in all cases are the same. The only thing that changes is what's out front. And so, as a rule, the graph is, or the equation is going to look something like this. It'll have a value followed by an x plus 5, I believe it was. No, it was a minus 5, sorry. X minus 5, an x plus 1, and an x plus 3. Even if I didn't write it in that order. Now I'm going to take that, if I can. Nope. Nope. Okay, so last question, last possibility really, is the question basically says, find me a very specific example. So again, this is a family of equations. That means there are a large number of them that fit the pattern, given the information that we had in example 1. Now this example in 2C is asking us to narrow it down quite a bit. It's saying, well, what if we want the one specifically that hits this point? And there will only be one. The negative 2, 6, we want to remember, is a point. So it's an x and a y that go together. 6 is the y value. A is our unknown. That's really what we're trying to find in this case. The x value given to us is negative 2. Sorry. My suggestion always when you're doing any kind of substitution is put the brackets in where you're going to plug in your numbers. So I substituted my brackets for x's here and then plugged in the negative 2. Once you've done that, of course, they're no longer necessary. So this is negative 7, this is negative 1, and this is positive 1, which means that 2 negatives on the one side make a positive, and we get A is 6/7, which means that our final answer, therefore, the equation is y equals 6/7 x minus 5, x plus 1, x plus 3.